Yes, friends, welcome back to Pyramid School. Today we're continuing with our normal follow of the pure mathematics syllabus, and we're going to look into factorization by handling some of these numbers, and that's we're going to see how to factorize them, and as well look into how we can use difference of two squares to simplify or factorize certain expressions. If you're new to the channel, I would recommend that you subscribe for more content and turn on that notification bell so that can be you can be alerted every time I upload new content. Please don't forget to like the video in case you enjoy it, and share the video as well to someone who might need it. So let's start away. As you can see, we are handling factorization, and we're going to start with that number 1. I'm going to go straight down until we reach here. So the first one, you can say our solution. Okay, let's handle number 1 first. Saying, oh, this one is cubed, this one is squared, this one is cubed here. So it's 4x cubed. This is cubed. Let me try to make it bold. So it's 4x cubed minus 4x cubed y squared minus 8x squared y cubed. So we can see that we just observe the common factors in these two terms, which we are getting a difference. So you realize that 4 is actually in that 8. X squared from here is inside that x cubed, and y squared from here inside that y cubed. So that means we actually have 4x squared y squared, which is a common factor in both those terms, of which we are getting the difference. So we can say that 4x cubed y squared minus 8x squared y cubed is going to be equal to 4x squared y squared, which is a common term we have pulled out, then into x. Since if we factorize 4x squared y squared, 4 will leave, x squared will leave x here, then y squared will remain in 1. So we remain only x inside, minus 2. X squared is already out, so all of that has died, because 8, when we factorize out 4 remains 2, then y squared when factorized out from y cubed remains y only. So when we factorize that, we end up with that expression. Okay, we go to the next number. I could say that let me write this side. It's saying that 2 here is saying that 2 as x squared plus 3x minus 18. First of all, what we have used here, we call it factorization by grouping or collecting of like terms. Meanwhile, here we're going to use a trial and improvement method, where we're just going to try to check for the factors of these. First of all, we need to know, the parts of a quadratic equation or a quadratic expression. We have the x squared term, the square term. We have the coefficient of the linear term, and we have the constant term. The constant term, that's negative 18, is considered to be the product of the quadratic expression, and this 3 in front of the x, which is the coefficient of x, is actually considered to be the sum. And one thing, the coefficient of of x squared here is the one which is used to determine the product. You always multiply the coefficient of x by that constant term to get the product of the quadratic expression. For this case, since it's 1, it will just remain negative 18. So to factorize it, we need to observe the factors of 18. Factors of 18, if we try to look for using a factor tree, divide that, we will have 9, divide by 3, we can divide that, we will remain 3, divide by 3, you remain 1. So the factors are actually this side, 2, 3, 3. So actually we can group any of those 2, 3, and 3 factors of 18. Okay, then we now play with the signs in order to bring that when we try to combine those factors in a way that we can bring a product of any of the combination that can give us negative 18, including the signs. When we play with the signs and we add those, we have to get the positive 3. Okay, so here we're going to have that. If you see, if we try to combine 3 and 3, then leave 2, that's 3. 2 and 3, if you combine this by multiplying them, we have 9. We'll see that we have no chance of getting 3. Even if you put negative here or put negative there, we have no chance of getting positive 3. Though if we multiply, if we put negative in any of them, we can multiply and get negative 18. So that wouldn't work. Let's try to combine these two. Let's say 2 and 3. 2 multiplying 3, and we pair with 3. So we are going to have 6 and 3. If you observe these other new factors that we have formed here, if we put a negative here, when you put a negative on 3, when we put a negative on 3, we're going to, and we try to add, we will end up with 3, and we multiply, we'll end up with negative 18. So 6 and negative 3 actually is a very good combination for us to get the sum and the to get the sum and the product of that quadratic expression. That implies that our x squared plus 3x minus 18 is actually going to be x squared plus 6x minus 3x then minus 18. Okay, x squared plus 6x minus 3x minus 18. So that 6x minus 3x will go back to 3x here. I think we have not changed anything, but we have just expanded it, so that we are going to have actually x squared. If you observe this, I want to write it clearly. 18. If you observe that, you're going to see that you have a common term. We try to pair them and try to factorize out the common ones. Okay. Let's have it down here. We're going to have x common in this first pair, which is x plus 6 that remains when we factorize out x from that. Then from this we have negative 3, which is also inside negative 18. So when we remove negative 3 out, we are going to remain with x plus 6 here as well. So that you'll see that the common factor again is x plus 6. So we're going to have x plus 6. Here will remain x. Then here will remain negative 3. So that therefore when we factorize x squared plus 3x minus 18, we end up with x plus 6 and x minus 3. So these are the factors of that quadratic expression. Okay, so hope we get that clearly. The next thing we're going to try to see an expression whereby the coefficient of the x squared term is not 1. So that takes us to number 3. Okay, we have, this is the same, these two expressions are the same, because when you reduce throughout by 2, you end up with that. So let's write the final one. We have 2x squared minus x minus 15. Okay, so I tell you the correct way of getting the sum here is to see the coefficient of the x, which is negative 1. Then product is actually the coefficient, we multiply the coefficient of x squared by the constant term, which will be negative 30. Okay, negative 30 is our product for this time. So we look for products for the coefficients. We're going to look for the for the factors of 30. We first deal with the, let's look for factors of 30 from this side. By 2 we have 15. By 3 we're going to have 5. Then by 5 we're going to have 1. Okay, so how can we need to combine this in a way that when we so now the factors, first of all, of 30 that we have here is going to be 2, 3, and 5. Okay, 2, 3, and 5. So we try to combine those factors in a way that when we try, so that we create a negative one in case we multiply. In case we add, and we get negative 30 in case we decide to multiply. So if I see the one that will bring us is easiest is going to be by multiplying 2 by 2 and 3, that to give us 6, then leaving 5 alone. Then bring about negative. If we bring negative on the bigger positive value, we're going to see that if we add this, we're going to end up with negative 1, and when we multiply, we end up with negative 30. So that makes our product to be our factors of negative 30 to be negative 6 and 5. That can suit that quadratic expression. Okay, so let's try to now go ahead, since we have got our negative 5 and 5 to be the real so now let's say our expression was 2x squared minus x minus 15 will now become 2x squared. Now this negative x is going to be replaced by negative 6x plus 5x, so that you see you've not changed anything to this. You've just created negative x in a different way here, negative 6 plus 5, then minus 15 will come this side. See, we have only changed this, which is negative 6x plus 5x. That's another way of writing negative 1 that we have got. And so now we're going to factorize our 2x. You will see that it's common throughout. You remain with x here, minus here remain with 3. If you see, when you factorize out 2x from these first two terms, then if you see when you factorize out you can see that you can factorize out 5. 5 is in 15 and in 5x as well, so you can say plus 5. Okay, so plus 5 will now remain here with x minus 3, and you'll still observe that x minus 3 is common throughout, so remain with 2x here plus 5. So that becomes the factors of this expression, 2x squared minus x plus 15. So that's how you factorize those ones without when the coefficient of x squared is not 1. That's how you get the product. You need to go back and multiply the constant term with the coefficient of x to get the right product for your quadratic expression. So for that you're done. Maybe I can leave you with 1 so that you can try out this 12x squared plus 17x. Then I can say minus 14. Try out to factorize that. As we move into the next thing, the next step, the thing that we're going to look at is actually the difference of two squares here. Try to see some examples, because there are some quadratic expressions that have the coefficient of x 0. The coefficient of x, like this. For this case, we have 17x, but we find it's 0x, so that actually it kills that x term, that linear term. So remain with only this and the square term and the constant term. So we look at one of those examples. So there we go, difference of two squares. Let's try to check for those examples. Number 1, I can say it's x squared minus 49. Okay, 49. So you need to observe that 49 is a perfect square, which is actually brought by squaring 7. So 49 will be split. You will have something like 7 squared. And according to difference of two squares, when you have a squared minus b squared, it can just be expressed in terms of a plus b into a minus b. So if you compare this and this, you realize that your a will be x and your b will be 7. So that you just say x plus 7 into x minus 7. That will be your result as when you factorize that quadratic expression. Okay. So let us check for the next one. Maybe let's say 12x squared minus 3. You realize that in 12 there is 3. Okay, so you first have to factorize out 3, so that remains 4 here. 4x squared minus 4x squared minus 1 here. Then you realize that 4 is actually given by 2 squared. So 2 squared, x squared, we can just put them under one bracket, which is that. So that there you'll have 2 squared x squared, which will go back to 4x squared. Minus 1. Remember 1 squared and 1 are actually the same. When you square 1, you remain with 1. So you can put that. So when you still compare with that a squared minus b squared, you realize that your a is actually 2x plus b, which will be 1. Then also you repeat that for when they're subtracting themselves, so that you end up with the factors of this to be 3 into 2x plus 1 into 2x minus 1. So that is what comes when you factorize 12x squared minus 3. Okay. So let's go to the next one. Still under difference of two squares. Let's say 5 tan squared theta minus 5. We're going to have here a 5 tan squared theta minus 5. You realize that 5 is still a common one in there. So you remain with that expression. And you also know that 1 can be expressed as 1 squared, right? And it still remains 1. So now you apply your difference of two squares there. Tan squared theta plus 1 into tan squared theta minus 1. Okay, that's what we have. So when you factorize out, when you factorize that expression, you come out with that. Hey, sorry, there's no squared anymore. I'm sorry. There was theta there. Let me rewrite this. 5 tan theta plus 1 into tan theta minus 1. Okay, squares are not there anymore because we are simply applying the concept that a squared minus b squared is the same as a plus b into a minus b. That's what we are trying to apply. So your a was actually tan theta and your b was actually 1. That's why you see that we have tan theta plus 1 into tan theta minus 1. That's it. So let's try to do the last one, which is asking us to evaluate. That's actually applying the difference of two squares. Let's say evaluate. That was number 3. Now here we go for number 4. Okay, evaluate 101 squared minus 100 squared. See, when you have difference of two squares and you see something like that, you can really apply it there. When you want to see a difference of two squares, you have a square which is 101 and another square 100. So you just can apply the difference of two squares, since you just the difference of two squares rule, since you're seeing that is a difference of two squares right there. So 101 squared minus 100 squared, according to our difference of two squares, it tells us we can just first add this, then multiply with that difference. Okay, that's it. We just, our a was now this time 101 and our b was 100, so that you can see that 101 plus 100 will actually be 201. Multiplying 101 minus 100 remains 100. So what does it mean? You're going to remain with 201 as the answer. See, you've saved very many steps rather than multiplying 101 squared alone, then multiplying 100 again. Now I'm applying 100 by itself again, then you get the difference. That would be a very long step. Please, thank you for coming to Pure Math School, and if I still insist that if you're new, please consider subscribing to support me and to follow more content. And also, please don't forget to like the video in case you enjoy it. Okay, let me remind you, please subscribe, like the video, okay, comment, share the video. Thank you so much for coming. Please see you in my next video. Bye.